Assalamualaikum warahmatullahi wabarakatuh. My name is Ani Suraya binti Sujari. My ID number is 2022923465. First of all, let's begin with the introduction. Land preparation for oil palm cultivation is a critical phase in establishing a successful plantation. This stage involves a series of processes designed to create an optimal growing environment for the oil palm, ensuring healthy growth and maximizing the yield. The preparation begins with site selection and assessment, where factors such as soil type, topography, and climate are evaluated to ensure they meet the requirement for oil palm cultivation. Once suitable site is identified, there are a few steps which are firstly, clearing the land. This involves the removal of existing vegetation such as trees and shrubs, which may compete with young oil palm plants for nutrients and light. The clear biomass is often managed through burning, composting, or other method, depending on environmental regulation and sustainability practices. The first one is moldboard plow. The moldboard plow, a fundamental tool in agriculture, has played a crucial role in the cultivation of various crops, including oil palm. The oil palm Elaeis ghanensis is a tropical crop that is a significant source of palm oil, widely used in food products, cosmetic, and biofuel. Efficient cultivation practices are essential to maximize yield and maintain soil health, and the moldboard plow is an integral part of these practices. The primary function of the moldboard plow is to prepare the land for planting by inverting the soil. This process involves cutting a furrow slice, lifting it and turning it over, which effectively breaks up the soil and creates a favorable seedbed. In oil palm cultivation, the plow helps in loosening compact soil, improving aeration and enhancing water infiltration. This is particularly important in tropical regions where heavy rainfall can lead to soil compaction. Next is tandem disc harrow. The tandem disc harrow is a pivotal agriculture implement designed to refine soil preparation, particularly in large-scale plantation like oil palm. As a significant crop in tropical region, oil palm demands meticulous soil management to ensure optimal growth and high yield. The tandem disc harrow plays a crucial role in this process, offering various benefits that enhance the cultivation of oil palm by improving soil structure, controlling weeds, and facilitating nutrient incorporation. The tandem disc harrow consists of two rows of concave discs arranged in an offset pattern. The design allows the implement to cut and turn the soil more effectively than single-row harrow. The discs are single to slide through the soil and organic matter, breaking it up and mixing it thoroughly. In oil palm cultivation, the tandem disc harrow is often used after the initial plowing to further refine the seedbed, ensuring the smooth and well-aerated soil structure that promote healthy root development.
Welcome everyone, my name is Izanada binti Mechat and today I will be introducing a strategy to optimize our farming operation, the computation method strategy. First, we need to identify the tasks we will be doing. For example, our group choose land preparation that involve primary tillage, moldboard plow, and secondary tillage with a tandem disc harrow. Next, we make some assumptions. These include the types of crop, the number of acres, working days, and total field hours. This help us plan accurately. Then, we figure out the number and size of the machine needed. We look at their power and capacity to ensure they fit our tasks. After that, we determine the machinery capacity. We assess how efficiently our machine can work in the field. Next, we compute the costs. These include fuel, maintenance, and other expenses. We also plan for long-term costs and break-even point. Finally, we set metrics and goals. These are key performance indicators to measure how well our machines are performing. In summary, the computation method strategy helps us use our machinery efficiently, manage costs, and achieve our farming goals. Now, let's explore each step in more detail. For the first step, we identify the operation. For land preparation, we use primary tillage with mold bulb plow, secondary tillage with a tandem disc harrow. Second step, we make some assumption which type of crop selected is oil palm plantation. Number of crop acres is 500 hectares. Number of working days is 35 days. Number of work hours per day is 8 hours. And total hours in the field is 218 hours. While in step 3, we determine machinery capacity for land preparation operation which given for moldboard plow, the speed is 8.1 km per hour and assume the width is 2.5 meters. While harrow, the speed is also 8.1 km per hour with the width 3 meters. From the given, we get a result of FC for both is 1.79 hectare per hour, TFC for moldboard plow is 2.025 hectare per hour, harrow is 2.43 hectare per hour. AFC for both is 1.79 hectare per hour. And last, FE we get for moldboard plow is 88%, while harrow is 74%. While in step 4, we determine the number and size of machine. For primary tillage, using a moldboard plow, total draft is 14 kN, power required is 19 kW, PTO power is 78.3 kW, and drawbar power is 68.12 kW. For secondary tillage, using a tandem disc harrow, total draft is 15 kN, power required is 34 kW, and drawbar power is 25.73 kW. From that calculation, we determine the number of machine needed for each implement. The number of tractor needed for both is 1 tractor, which calculation for primary tillage 0.99 tractor equivalent for 1 tractor, and calculation for secondary tillage is 0.84 also equivalent to 1 tractor. So, we decided to use 1 tractor with suitable engine power for both implements.
Next, in this section, I will explain how we compute the fixed cost associated with our machinery, focusing on depreciation. So this is a depreciation calculation which is start by assume 1 kilowatt equal to 1000. So the year age of tractor are 6 years and cost of machines are 78,300 by multiply the 78.3 kilowatt which 100. The useful life are 10 years and the salvage value are 10%. So the total of average annual depreciation is 7,047. So by understanding and planning for this fixed cost, we can better manage our budget and ensure the financial sustainability of our operations. Next, I will continue to the fixed cost, which is first tax. The total of tax is 1,566, which is by multiply the cost of tractor, which 2%. So the total is 722 and 36 cents. So third, for the insurance, this is calculated based on the value of the tractor, and the total is 391 and 50 cents. Lastly, for the fixed cost interest of investment, which is calculated based on the cost of the tractor. So the total is 6,264. Next, we move to the total fixed cost. After sum all the costs, the total are 50,988.80 cents per annually. So by understanding this fixed cost, we can better plan our budget and ensure financial sustainability. Second component are operating costs. First is labor, which is 10 ringgit per hour multiplied with 280 hours, and the total of cost for the operations are 2,800. Second, we calculate the fuel cost for both operation, which is we need to calculate a two-step, which is the average fuel consumption and average fuel cost. So the total cost of fuel is 58 ringgit 49 cents per hour. So third, the amount of lubricant, which is calculate 10% of the fuel cost. So the lubricant cost is 5 ringgit 85 cents per hour. So and lastly, about repair and maintenance, which is based on the table of accumulated repair cost. So the total for the repair maintenance 40 ringgit and 49 cents. So for the last step, we need to total all the operating costs, and after sum all the calculation, the total are 100
14.83 cents per hour. So by understanding this operating cost, we can better manage our budget and ensure efficient use of our machinery. Next, I will explain how we calculate the total cost per hectare, which is fixed cost plus by operating cost. But first, we need to divide the total of fixed cost with the total hours of tractor used annually. So after that, we can calculate as usual, which is got 69 ringgit and 05 cent per hectare. So by understanding this cost, we can better plan our budget and ensure efficient use for our resources. So next, I will explain our long-term plan trading strategy, focusing on the usage and trade timeline of tractor use. So the normal rate of usage, this is calculated as half of the least cost life of the tractor, and high rate of usage, this is calculated as 3/4 of the least cost life. So we jump to the calculations. For the normal rate of usage, we take half of the least cost life, which is multiplied with 8,500 and got 4,250 hours. For the high rate of usage, we take 3/4 of the least cost life, which is multiplied with 8,500 and got 6,375 hours. So next, we need to determine the earliest feasible years to trade, which is normal usage are 15 years and high usage are 22 years. This long-term plan ensure that we balance between cost efficiency and the operational effectiveness of our machinery. As are about the break-even point, which is the area in hectare, where the cost of owning the operations, the machinery is equal to the revenue generated. So for the tractor and combine the calculation, first we calculate the average annual fixed cost, which is 11.82% multiplied with 78,300 and got 9,255 and 06 cents. Then we use this value to find the break-even point that got 165 hectare. So this means that we need to till at least 165 hectare to cover the fixed and operating costs of owning and using the tractor and combines. So understanding this break-even points helps us plan our operations more effectively and ensure that we are covering our costs before making a profit.
My name is Nur Fatiha Hazika binti Zulkifli. My student ID is 2022991079 and I am going to present the conclusion of this study. Today, I will be presenting the result of our computational study on selecting the optimal tractor for the primary tillage activity in an oil palm plantation. Our analysis has led us to recommend the John Deere 6110M utility tractor. Based on a comprehensive computational analysis, we examined that various factors including field capacity, power requirement and cost effectiveness to determine the best tractor for the 500 hectare of oil palm plantation. The John Deere 6110M utility tractor boasts a field capacity of 1.79 hectare per hour and an effective field capacity of 88%. This high efficiency makes it an excellent choice for preparing the large area of 500 hectare within the given time frame, ensuring that we can complete the task efficiently and effectively. The tractor's drawer power requirement is 68.12 kilowatt, which aligns perfectly with John Deere 6110M capabilities. This guarantees that the tractor can manage the necessary soil resistance and draft, further supporting its suitability for our primary tillage operation. One of the key findings of our analysis is the cost effectiveness of using the John Deere 6110. The study showed that the only one tractor with a 3-meter implement is needed for the task, highlighting significant cost saving. this tractor can handle the workload with minimal equipment, ensuring operational effectiveness and cost efficiency. Our cost study, which include fuel and lubrication expenses, confirmed that the overall cost per hectare is reasonable and sustainable for long-term operation. This balance of power, efficiency, and cost effectiveness make the John Deere 6110M not just a practical choice, but also a strategic investment for our oil palm plantation project. In conclusion, the John Deere 6110M utility tractor provides a balanced solution in terms of power, efficiency, and cost. It meets the demanding needs of soil preparation, offers high operational efficiency, and endures durability and reliability. Therefore, it is an optimal choice for primary tillage operation in our oil palm plantation, making it a recommended and strategic investment for achieving sustainable agriculture practice.